Usually, when we think about our relationship with tools, there's this built-in expectation of passivity,
Right,
right?
yeah, like they just wait for us to do something.
Exactly. Think about a hammer. It just, sits there on the workbench.
Completely inert.
Yeah, it has no agency, no intent, uh, no utility at all until you physically pick it up and swing it.
Right, it's essentially Newton's first law applied to human engineering.
Okay, I like that.
Yeah, a tool stays at rest until acted upon by a human operator. The flow of kinetic energy and, well, purpose, really, is entirely a one-way street, from us to the tool.
But if you look at the landscape of artificial intelligence right now,
Oh, man.
in the spring of 2026, that fundamental law is just completely breaking down.
It really
The
is.
hammer is waking up, basically. It's looking around the workbench, evaluating the different sizes of nails, and it's proactively asking you what kind of birdhouse you want to build.
Which is a huge shift.
We are living through this crazy technological transition from
Mm.
passive tools to active participants.
And that completely redefines the division of labor between humans and machines. I mean, we're migrating from an era of software that, waits for explicit commands.
To an era of systems that initiate autonomous action.
Exactly. Actions based on high-level goals.
Well, welcome to the deep dive. Whether you're an undergrad tech student currently cramming for a systems architecture final,
Good luck with that, by the way.
yeah, good luck. Or maybe you're a developer trying to optimize your deployment stack, or you're just someone trying to make sense of the absolute avalanche of AI news that dropped between mid-April and early May 2026, you are in the right place.
There is a lot to cover.
So much. Our mission today is to cut through the marketing noise of the latest model drops, and we've gathered a massive stack of sources for you.
We really went deep on this one.
We did. We've got deep technical engineering blogs from NVIDIA, Hugging Face, DeepMind, LM, Plus, we're pulling in the macro-societal data from the Stanford AI Index.
Right, and the real-world deployment reports from the South China Morning Post and Argosy.
Exactly. We're going to stitch all of this together to figure out how this agentic shift is actually being built, how it perceives the world, and honestly, where it's fundamentally bottlenecking right now.
And what's crucial to understand here is that the developments over these past few weeks, they aren't just iterative software patches.
No, not at all.
We're seeing major architectural pivots, like at the silicon and memory levels, just to support this new paradigm.
So let's start right there, at the foundation layer, the actual engines driving this shift.
Sounds good.
Because for the past few years, the industry was just obsessed with raw parameter count, right?
Oh, absolutely. It was just a brute force arms race.
But looking at the release of DeepSeek V4, the obsession has clearly shifted to context and efficiency.
The sheer scale of working memory that DeepSeek has managed to unlock with V4 is, it's staggering, honestly.
They launched their V4 API with a 1 million token context window.
Yeah, 1 million.
And the market shocker wasn't just the memory size. They simultaneously slashed their API prices by up to 90%.
Which is just unheard of.
Plus, they added native AI vision.
Right.
The South China Morning Post actually had this great headline about the release saying, the whale can now see. They slotted a new image recognition mode right alongside their expert and flash chat modes.
Yeah, the vision aspect is huge, but I really want to look at the engineering reality of this 1 million token context for, our undergrads studying system architecture.
Let's do it. Because 1 million tokens isn't just like reading a long book.
Not at all. The technical overhead to maintain that state is massive. It's a severe architectural challenge.
Break it down for us.
Okay, so when a transformer model processes a prompt, it stores the representations of those tokens in what's called the key value cache, or KV cache.
Right.
Historically, the memory required for the KV cache scales linearly with the sequence length,
Okay, that makes sense.
but the attention computation scales quadratically.
Oh, wow.
So if you push 1 million tokens into a standard architecture, the KV cache alone would just explode. It would consume hundreds of gigabytes of VRAM.
You'd basically exhaust the high bandwidth memory on an entire cluster of GPUs just to hold the context.
Exactly, leaving zero compute available for actual generation. You could hold the thought, but you couldn't do anything with it.
Which means the underlying math of how the model pays attention to its own memory, that had to change.
Precisely. So offer 1 million tokens at a 90% price reduction, DeepSeek couldn't just, throw more hardware at the problem.
That would be way too expensive.
Right. So they're relying on highly optimized architectural techniques, likely variations of multi-head latent attention.
Or aggressive KV cache quantization, right?
Yes, exactly. Techniques that compress that memory footprint without catastrophic degradation. And this is where tools like SGLang come in,
Right, they offer days or support for serving DeepSeek v4.
which is critical because SGLang uses techniques like radix attention to share that massive KV cache across multiple requests.
Making it economically viable to serve at scale.
Yes.
I hear that. But I have to push back a little on the actual utility of this. Let me float a theory by you.
Okay, go for it.
Does a massive context window inherently mean better reasoning? Or are we just building a giant haystack and hoping the AI can still find the needle?
That's the big question.
Right, because if I put my entire 4-year computer science syllabus, every textbook, every lecture transcript, every piece of code I've ever written, if I put all of that onto a giant desk simultaneously, it doesn't mean I actually understand how they connect.
No, it just means your desk is incredibly cluttered.
Exactly. So does the model actually know what to do with 1,000,000 tokens?
That skepticism is exactly what Hugging Face researchers have been highlighting in their recent commentary.
Oh, really?
Yeah, the metric that matters isn't the absolute size of the context window, it's the retrieval accuracy at the extreme edges of that window.
The whole needle in a haystack evaluations.
Exactly. If you drop a single, highly specific financial variable onto, say, page 400 of a 500-page localized context.
Can the model pull it out reliably?
Right. Hugging Face points out that it's about having 1,000,000 token context that agents can actually use.
Because if it forgets half the document.
Right. If the model's attention mechanism degrades over long sequences, if it suffered from that lost in the middle phenomenon where it just forgets the center of the prompt, then the 1,000,000 tokens are useless for complex, multi-step agentic tasks.
So the real engineering achievement of V4 is maintaining a flat retrieval accuracy curve across that vast expanse of data.
That is the true breakthrough, yes.
Okay, so DeepSeek is solving the problem of massive, cheap, accessible memory. But at the exact same time, in April 2026, DeepMind dropped Gemma 4.
Yes, they did.
And they took a completely opposite philosophy. They aren't bragging about 1,000,000 tokens at all.
No, they are explicitly claiming that Gemma 4 models are, byte for byte, the most capable open models.
Byte for byte. I love that phrasing.
It perfectly illustrates the current bifurcation in machine learning strategy right now.
How so?
Well, DeepSeek is scaling out the infrastructure for massive cloud workloads, right?
Yeah.
DeepMind, with Gemma 4, is aggressively focusing on parameter efficiency. They are likely overtraining these models far past the traditional compute optimal scaling laws.
So for the undergrads listening, that means they're feeding a relatively small model an absurdly massive amount of highly curated, high-quality data during training.
Exactly.
It's basically the difference between building a massive, cheap warehouse to store everything versus building a highly efficient, perfectly organized, tiny home where every single square inch serves a dual purpose.
I love that analogy.
Oh,
and that tiny home approach is vital for the edge.
Right, for running locally.
Yeah, if you want a model to run locally on a smartphone or a drone or a piece of medical equipment without pinging a cloud server.
You need maximum reasoning capability in the smallest possible memory footprint.
You need every single weight and bias in that neural network to punch far above its weight class.
But, whether you have the massive warehouse of DeepSeek or the optimized tiny home of Gemma 4, we run into the same fundamental limitations.
That's just...
A brilliant memory and a highly efficient reasoning engine are great, but they are still passive. They are still just hammers sitting on the workbench waiting for a prompt.
Right. Which brings us to the operational shift.
How we take these foundation models and turn them into entities that can execute tasks.
Exactly. The shift from passive thinkers to active doers.
And Ant Group just made a massive wave in this space by open sourcing Ling 2.6 Flash.
That was a huge release.
Yeah, it's a 104 billion parameter model. And the key detail from the Pandaily source is that it is explicitly optimized for agent tasks.
Right.
But what really jumped out at me for the developers listening is the underlying mechanics of how it runs. It uses multiple precision options to match the performance of much larger models at a fraction of the compute cost.
Well, let's dig into that because it's fascinating.
Please do.
This touches on the von Neumann bottleneck, which is really the primary constraint in modern AI hardware. The actual compute cores on a GPU are incredibly fast, but moving the data that the model waits and activations from the GPU's memory to those compute cores takes time and energy.
So it's a traffic jam.
Exactly.
Yeah.
Historically, models use high-precision data types, like 16-bit floating point or FP16.
Let me try to visualize this. Tell me if this works.
Okay.
If I'm an architect sketching out the rough dimensions of a room on a napkin, I don't need to calculate the measurements to the 16th decimal point. I can just round to the nearest inch using a thick marker.
Sure.
But when I'm actually on the construction site cutting expensive mahogany wood, I need absolute high precision, so I use a laser measure and a fine-tip pen.
That's a highly effective way to understand quantization, actually.
Okay, good.
The thick marker is INT4, or 4-bit integer precision. The fine-tip pen is FP16. What LMSYS and other research labs have shown is that neural networks are surprisingly resilient to noise.
They don't need the fine-tip pen for everything.
Right, you don't need high precision for every single calculation. By allowing Ling 2.6 flash to dynamically use lower precision formats like FP8 or INT4 for specific layers or attention heads.
You drastically compress the size of the data, you're shrinking the numbers, which means you can shove more of them through the memory bandwidth pipeline per microsecond.
Exactly. You alleviate the memory bandwidth bottleneck.
That's incredible.
It allows a 104 billion parameter model to execute complex multi-step agentic tasks like, scraping a website, writing a Python script to analyze that data, and debugging the errors with the speed and fluidity of a model twice its size.
It's all about maximizing the utilization of the silicon.
Precisely.
Okay, so Ant Group is optimizing the math at the precision level. But Tencent took a totally different architectural approach to building agents, right?
Yeah, they did. They just open sourced the HY3 preview.
Which is a 295 billion parameter model, but it's a mixture of experts, or MoE architecture.
Which is another massive strategy for circumventing compute bottlenecks.
How does that one work?
Well, in a standard dense model, like the early generations of LLMs, every single parameter is activated for every single query.
Every single time.
Every single time. So if the model has 300 billion parameters and you ask it, what is the capital of France?
It runs the math through all 300 billion parameters just to output Paris.
Yes. It's a massive waste of computational resources.
It's like going to a hospital for a paper cut, and the hospital mandates that the neurosurgeon, the leading cardiologist, and the physical therapist all have to stand in the room to consult on your Band-Aid.
A catastrophic misallocation of expertise.
Exactly.
So in a mixture of experts architecture like HI3, the 295 billion parameters are divided into smaller, specialized subnetworks. The experts.
Okay.
When a prompt enters the network, a routing algorithm analyzes the tokens and dynamically decides which experts are best suited to handle them.
So for that simple geography question,
The router might only activate a 15 billion parameter subnetwork, completely bypassing the other 280 billion parameter.
the triage nurse just sends you to the general practitioner.
Correct. You get the knowledge capacity of a 295 billion parameter system, but the inference cost and latency of a much smaller model.
That is so elegant.
It is. But if we look at the analysis from DigiChina and Pandaily, the real breakthrough with Tencent's HY3 isn't just the MoE weights.
Oh, what is it?
The story is what Tencent is building around the model. They are heavily betting on what they call the harness layer.
Let's unpack the harness layer, because I think this is where a lot of people misunderstand what an agent actually is. The sources describe this as the engineering scaffolding, the tools, the memory systems, the workflow loops.
Right, because the foundation model, the neural network itself, is just a statistical pattern matcher.
It predicts the next token.
Exactly. It doesn't inherently know how to click a mouse or query in SQL database or remember what it did 10 minutes ago? The harness layer is the software infrastructure that wraps around the model to give it those capabilities.
I look at it like dealing with a disorganized genius.
Okay, let's hear it.
The raw foundation model is a brilliant savant with a photographic memory of the internet. But they have no short-term memory, they don't own a calculator, and they refuse to write anything down.
They can't actually complete a project.
Right. The harness layer is like hiring a highly efficient executive assistant for that genius. The assistant gives them a filing cabinet for short-term memory, hands them a calculator when they need to do math, and forces them to review their work before submitting it.
And that review process is critical.
Right.
The prevailing framework for this is called REACT, reasoning and acting.
React, right.
The harness prompts the model to generate a thought, take an action based on that thought, observe the result of that action, and then generate a new thought.
But I have to ask, aren't we kind of over-engineering this?
What do you mean?
Well, with DeepSeek giving us 1 million tokens of context and Gemma 4 giving us hyper-optimized reasoning, why do we need all this complex external scaffolding? Shouldn't a model with 295 billion parameters just, know how to output a perfect, flawless sequence of code to solve my problem in one shot?
I mean, in a sterile, static environment, maybe.
Okay.
But agents operate in the real world, and the real world is chaotic. A web page takes too long to load, an API endpoint changes its formatting, a server throws a 504 error
Things break.
constantly, and the model's weights cannot predict these dynamic failures. If a model tries to generate a 100-step plan in one shot and step 3 fails,
Then steps 4 through 100 are completely invalidated.
exactly. The harness layer provides the cognitive loop required for resilience. It allows the agent to attempt an action, observe the failure, analyze the error message, correct its own logic, and try a different approach.
So the foundation model is the raw computational cortex, but the harness layer acts as the prefrontal cortex.
Managing the executive function, the tool use, and the error correction.
Exactly. The harness transforms raw intelligence into applied utility.
Precisely.
But this sets up a massive collision course, because if these harnessed agents are going to interact with dynamic real-world environments, they are severely bottlenecked if they can only perceive the world through text prompts.
Text is a very low bandwidth abstraction of reality.
Right.
If agents are going to operate autonomously, they need to ingest reality natively.
Which brings us to a massive paradigm shift in edge computing: multimodal unification.
This is huge.
In late April 2026, NVIDIA launched the Nematron 3 Nano Omni model. The headline stat from the NVIDIA engineering blog and Hugging Face is that this model unifies vision, audio, and language natively, resulting in AI agents that are up to 9x more efficient.
Incredible jump in efficiency.
Yeah, let's break down that word natively, because we've had multimodal AI for a while, right? I could talk to my phone and it would talk back. But that was a stitched-together system.
Right. In a stitched-together or cascaded pipeline, you have multiple isolated neural networks.
Okay, walk us through that.
When you speak, an automatic speech recognition, or ASR model, converts your audio waveform into text.
Step 1.
Right. That text string is then passed to the large language model, which generates a text reply.
Step 2.
Then a text-to-speech model takes that reply and synthesizes an audio waveform.
3 separate models running sequentially.
Exactly.
It's like translating a joke from Japanese to German and then to English.
Yeah, that's a good way to look at it.
Sure, the literal words make it to the end of the pipeline, but the high-dimensional data, the comedic timing, the sarcastic tone of voice, the cultural inflection, it's completely stripped away and destroyed in the translation process.
That is the perfect analogy for the loss of high-dimensional data. When an ASR model converts a human voice to text, it deletes the emotion, the hesitation, the background noise. It turns a rich waveform into a flat string of characters.
Just dead text.
Exactly. But a native multimodal model, like Nematron 3 Nano Omni, utilizes early fusion.
Early fusion.
It ingests the raw audio waveforms and the raw video frames directly into the same shared embedding space as the text.
So it isn't playing telephone with itself.
No, not at.
When it hears you speak, it isn't reading a transcript of your voice. It is mathematically processing the actual sound waves.
Exactly. The neural network learns the correlation between the tone of a voice, the visual microexpressions on a face, and the semantic meaning of the words simultaneously.
That's wild.
It is. This not only preserves all that rich, high-dimensional context, but it drastically reduces latency. You aren't waiting for 3 different models to finish their discrete tasks. The processing is instantaneous.
And that instantaneous processing is why NVIDIA is reporting a 9x efficiency gain for agents.
Right.
Because if an agent is running locally on a robot or a smart device at the edge, it can't afford a 2-second latency delay while it translates a video feed into text. It needs to react to dynamic stimuli in milliseconds.
And keeping the ecosystem integrated, Nematron also received Day Zero support from SGLang.
Which again is crucial for developers.
Absolutely. SGLang excels at structure generation control. When you have a multimodal agent making rapid decisions, you need to constrain its outputs to specific formats like JSON.
Right, so that other software systems can parse its actions reliably.
Exactly. SGLang provides that strict grammar enforcement at the edge without slowing down the inference speed.
And to demonstrate the real-world power of this local, highly efficient multimodal processing, NVIDIA highlighted something truly fascinating: the UK LLM initiative.
Oh, this is a great project.
They are using Nematron to bring AI natively to the UK's oldest living languages: Cornish, Irish, Scottish Gaelic, and Welsh.
This is a profound application of the technology, and it intersects heavily with the global movement toward sovereign AI.
We hear sovereign AI thrown around in press releases all the time, but what does it actually mean for a developer in Wales building an agent?
Sovereign AI is the geopolitical and cultural stance that a nation, a community, or an enterprise must control its own artificial intelligence stack.
Meaning they don't want to outsource it.
Right. The alternative is sending all of your cultural data, your language nuances, and your intellectual property to a massive server farm in California or Shenzhen to be processed by a black box model.
Which is a huge privacy and cultural risk.
Exactly. By utilizing a highly capable, edge-deployable model like Nematron, the UK LLM initiative can train and run agents locally.
They are decoupling their cultural heritage from the centralized tech monopolies.
Precisely. A localized Nematron agent can listen to a spoken Irish dialect natively, process the audio waveform locally on a sovereign server, and respond with cultural and linguistic accuracy without ever transmitting that data across international borders.
Wow.
It secures data privacy and prevents minority languages from being homogenized by generalized global models.
It's basically giving these ancient, beautiful languages a digital heartbeat on their own terms.
It really is.
But, this brings up a terrifying bottleneck.
Let's hear it.
We have just established that we are deploying massive context windows, efficient MoE routing, agentic harnesses that loop and act autonomously, and native multimodal sensors running at the edge.
Right, we've built some incredibly powerful systems.
So if an agent is taking 1,000 microactions a minute locally, how on earth do you evaluate if it's safe? You can't just read the transcript anymore.
No, you can't. And that friction is the absolute bleeding edge of the AI crisis right now.
Because Hugging Face researchers recently published a stark warning about this.
Yes, they declared that AI evils are becoming the new compute bottleneck.
I really want to drill into this because on its face, it sounds paradoxical.
How so?
Training a foundation model costs tens of millions of dollars in GPU compute. How can the test cost more than the training? Are we hitting a fundamental wall in computer science where we can't afford to grade the exams we're writing?
We are rapidly approaching that wall, yes.
Explain that for us.
To understand why, you have to look at how evaluation metrics have evolved. 2 years ago, we evaluated chatbots using static benchmarks.
Like a standardized test.
Exactly. You ask the model a multiple-choice question, it outputs C, and you check if C is the correct answer. It is a linear O1 computation. It costs fractions of a cent.
Right, simple input, simple output.
But an agent, by definition, is nonlinear. If you want to evaluate an agent powered by Ling 2.6 Flash or Tencent HY3, you can't just ask it a question.
What do you do instead?
You have to drop it into a simulated sandbox environment, say a simulated AWS cloud architecture, and give it a high-level goal, like audit this database for security vulnerabilities and patch them.
And to do that, the agent has to take hundreds of sequential steps.
Hundreds or thousands. It has to navigate the terminal, write scripts, read logs, and correct its own syntax errors. To evaluate if that agent is safe, capable, and aligned, the testing framework has to simulate the entire environment perfectly.
That alone sounds incredibly resource-intensive.
It is. But furthermore, it has to track the branching decision tree of every single action.
Oh, wow.
Did step 45 inadvertently open a back door? Did step 81 hallucinate a dependency that doesn't exist? You end up running Monte Carlo simulations of complex environments just to score a single workflow.
That's insane.
The computational overhead required to simulate the sandbox and verify the multi-step logic is monumental.
So we are building race cars that drive so fast and take so many different branching routes simultaneously that we literally don't have enough safety inspectors or radar guns to track them.
That's exactly what's happening.
The capability of the model is outstripping the economic feasibility of measuring it.
And when you cannot rigorously measure a system, deploying it becomes an exercise in risk tolerance.
Which is terrifying.
It is. And this technical bottleneck is directly mirrored by a widening societal gap, which is rigorously detailed in the new Stanford AI Index 2026 report.
Ah, the Stanford HAI report. That's the gold standard for global macro data on artificial intelligence.
It really is.
And this year's report is sobering. They explicitly highlight that while technical capabilities like the multimodal native processing we discussed are accelerating exponentially, societal readiness is stalling.
It's a huge disconnect,
And one of the most alarming metrics they flagged is a sharp decline in data transparency.
which severely exacerbates the evaluation bottleneck we were just talking about.
How so?
As these models transition from research projects to massive commercial engines, the corporations building them are slamming the doors shut, The training data mixtures, the reinforcement learning protocols, the specific routing algorithms in the MOE architectures.
They are all becoming highly guarded trade secrets.
Exactly. For independent researchers or academic institutions trying to build safety evaluations, they are essentially trying to reverse engineer a black box.
You can't verify the safety of a system if you don't know what ingredients went into the batter.
Precisely.
But what I found most fascinating in the Stanford data is the stark divergence in global public sentiment.
Yes, that was a key finding.
While the American market is showing high levels of anxiety and nervousness regarding AI adoption, the Chinese market is indexing highly on excitement and optimism.
This divergence is going to dictate the physical infrastructure of the future. Public sentiment is not just a feeling, it is the primary driver of regulatory policy.
And regulatory policy dictates market deployment speed.
Exactly. If you are an enterprise CIO in a market governed by anxiety, you are going to face massive internal friction, compliance audits, and strict guardrails before you are allowed to deploy an autonomous agent into your workflow.
Because everyone is terrified of the risk.
Right. Conversely, in a market driven by excitement and rapid adoption, you will see the frictionless, ubiquitous integration of these agentic harnesses into daily life.
So the technological breakthroughs we've discussed, DeepSeek's massive context, Gemma's edge efficiency, Nimatron's instantaneous vision, these aren't going to roll out globally in a synchronized way.
Not at all.
They will be deployed at vastly different velocities depending entirely on the localized human variable.
Which is going to create a very fragmented global landscape.
But despite the evaluation bottlenecks and the regulatory friction, real-world deployment waits for no one.
It really doesn't.
Let's look at how this technology is actually manifesting in the real world right now, in the spring of 2026. This brings us to our final exploration, novel applied machine learning.
This is where it gets really tangible.
And what we are seeing is a massive shift from models that just generate text to models that perform high-stakes discrimination.
Yes, we are seeing AI transition from a creative co-pilot to a superhuman pattern recognizer in life or death scenarios.
Look at healthcare. According to the sources at Pandaily, Alibaba's DMO Academy has successfully deployed an AI model that can detect colorectal cancer directly from routine CT scans.
Wow, that is incredible.
And the breakthrough here is that it achieves this without the patient needing to undergo the invasive, uncomfortable preparation that usually accompanies colonoscopies.
This is the power of discriminative AI. Generative AI creates novel outputs, like a poem or an image.
Right.
Discriminative AI analyzes incredibly complex, messy, real-world data distributions, like the millions of pixels in a CT scan, and identifies the invisible mathematical boundaries that separate healthy tissue from a microscopic tumor.
It finds the hidden manifold that the human eye simply cannot perceive,
Exactly.
finding the tumor in the noise. And it's happening at the molecular level, too.
What's happening there?
The South China Morning Post reported that ByteDance, the parent company of TikTok, has a dedicated drug discovery unit that is actively presenting AI-designed therapies at global medical conferences in Boston and Barcelona.
Wow, so they're moving beyond social media algorithms.
Way beyond. They are using these models to simulate protein folding and molecular binding at speeds that physical laboratories can never match.
It accelerates the pipeline of human survival.
And it scales beyond the human body to the planetary body.
Explain that one.
International researchers in Poland are leveraging deep learning architectures running on massive clusters of NVIDIA GPUs to track atmospheric water vapor.
How would end?
They are processing immense data sets of meteorological noise to generate highly accurate, localized weather forecasting. They are predicting the storm before the clouds even physically form.
That is fascinating. Whether it is a CT scan, a molecular structure, or atmospheric water vapor, the underlying mechanism is the same.
Which is?
The models are ingesting vast amounts of high-dimensional reality and outputting actionable certainty.
Actionable certainty, I like that. It's touching the physical atmosphere. But what I find even more profound is how it's touching the emotional atmosphere.
Oh, definitely.
If we look at culture and entertainment, the capabilities of agentic workflows are fundamentally altering human media consumption. The SCMP reports that China's supply chain is currently harnessing AI pipelines to churn out 500 AI-generated microdramas per day.
500 a day.
500 complete, structured narratives generated daily.
The scale of content generation has completely decoupled from human production limits.
It really has.
When you have agents that can draft a script, generate the video frames natively, synthesize the audio dialogue, and edit the final cut in an automated loop,
Hmm.
the marginal cost of entertainment drops to zero.
But it gets so much more intimate than just watching a generated TV show.
How so?
In Seoul, there is a massive rising trend of what are being called AI shamans.
AI shaman.
Yeah, people are consulting artificial intelligence systems that have been fine-tuned on ancient fortune-telling logic, astrology, and spiritual texts to predict their futures and guide their life choices.
That is wild.
Furthermore, there is a widespread trend of people relying on digital AI exes, custom-prompted AI replicas of their past romantic partners to help them process grief, heal from heartbreak, and find emotional closure.
This completely recontextualizes everything we've analyzed today.
It does, doesn't it?
When you look at the phenomena of AI shamans and digital X's, it proves a vital point.
Hmm.
Humanity does not just want artificial intelligence for economic productivity.
We aren't just using Ant Group's Ling model to write Python code faster.
Exactly. Or DeepSeek's massive context to
Yeah.
parse financial PDFs. We are actively seeking out these neural networks for emotional resonance. We are turning to them for entertainment, for psychological safety, and even for spiritual comfort.
It is profound. We are using deep learning to predict the physical weather in Poland, and we are using it to predict our romantic fortunes in Seoul. The models are becoming interactive mirrors for the human psyche.
And because they are becoming native, multimodal, and agentic, those mirrors are becoming incredibly immersive.
Right.
They don't just text you, they see you, they hear your tone of voice, and they respond in real time.
Okay, let's take a step back and synthesize this incredible landscape. We started by looking at the foundation layer, where DeepSeek v4 proved that we can manipulate the KV cache to hold 1 million tokens of context, while dropping compute costs by 90%.
And we saw DeepMind's Gemma 4 prove the absolute power of byte-for-byte parameter optimization for the edge.
Then we explored the operational shift. Ant Group's Ling and Tencent's HY3 introduced us to the power of dynamic precision quantization and MOE routing.
But more importantly, they highlighted the necessity of the harness layer, the external memory and tool use loops that turn passive models into active, resilient agents.
We saw NVIDIA's Nemotron give those agents native, instantaneous, multimodal senses, stripping away the latency of stitched-together models and enabling sovereign AI like the UK LLM initiative.
We faced the harsh systemic reality of the evaluation bottleneck, where it cost more to simulate the safety test than to train the model.
And we saw how global sentiment divergence in the Stanford report will dictate regulatory speed limits.
And finally, we saw the combination of all this architecture deployed in the real world. Discriminative models finding tumors and predicting weather, while generative agents flood the market with microdramas and act as spiritual and emotional companions.
It is a breathtaking pace of innovation, and it truly requires a structural shift in how we think about our own utility. Which brings me to a final thought for you, the listener, to mull over.
A very important thought.
We've established that open-weight models are becoming essentially free, and agentic harnesses are capable of executing complex, multi-step code, debugging themselves, and navigating the web autonomously. Therefore, the future of computer science is no longer about writing the syntax of the code yourself. The machine can do that natively.
So what is the future?
The future is about managing a distributed team of AI agents. So the provocative question for you to explore is this. As you sit in your systems architecture class, or as you optimize your enterprise stack, are you actually training to be a software engineer? Or are you, in reality, training to be an AI psychologist and a middle manager?
It's a great question.
Think about how you interact with a system that has 1 million tokens of memory, a specialized routing network, and an autonomous execution loop. Because the hammer isn't just sitting on the workbench anymore. The tools aren't just swinging themselves. They are looking up at you with native multimodal vision and asking what you want to build next.
A profound and permanent shift in the division of human labor.
Thank you to our expert for the incredible, deep, technical analysis today.
It is always a privilege to unpack the architecture of these complex systems with you.
And thank you for joining us on this deep dive. Stay curious, keep questioning the architecture, and we will see you next time.